Hi friends, welcome back to another session of ECE Made Easy. We are in our first section which deals with the basic elements. In this, we are now looking into the basic components used to build electric and electronic circuits. In this series, we have seen the basic concepts about resistance and capacitance. Now it is time to look at what inductance is and how that will be useful for our future. So inductance is something to do with the electric current. The word inductance is directly related with the electric current, and the electric current means the electric charges in motion. So if there is any flow of electrons, then there is a current, and if this flow of electron is in a particular direction, then all the electrons together cumulatively create a current, and the current in turn creates a magnetic field. So you just imagine that there is a wire, and through this wire a current is flowing. The current of I amperes is flowing through this wire, and because of this wire a magnetic field is produced around this, and as per Faraday's right hand rule, if the thumb is direction in the direction of the current, then the curled fingers of right hand will tell in what direction the magnetic field would be. So that's the basic of creation of a magnetic field. So wherever there is a current, there exists a magnetic field around in the space, and this magnetic field depends on the strength of the current and the property of the medium, and the property of the medium which is used in this case is called a permeability. The basic nature of a magnetic field is to oppose change in current. So something to do with the momentum. So it will not allow a sudden change in the velocity of any body. The current here is related with the motion of electron. So that means the faster the electrons are moving, the higher will be the current. So we can correlate the current with the velocity of any body, and when there is a body moving, then the body will have its own momentum depending on its mass and the speed, and this momentum will not allow the sudden changes in the velocity, and similar opposition we get from the property called the magnetic field. So whenever there is change in the electric current, then an equal and opposite electric field is created that produces current to nullify the change. So nullifying the change means if the current has increased in this direction, then some electric field is created in this direction that will create a current in the opposite direction, so that the change in the current is nullified by this potential. And this concept is called the electromotive force, which very commonly we call as EMF. In our common terms, we refer to it as voltage. So whenever there is current flowing in a conductor, there do exist a magnetic field, and the tendency of the magnetic field is to oppose change in the current. If there was no current, there was no magnetic field, but suddenly if the current starts to increase, then magnetic field is created, and the created magnetic field tries to oppose this change in the current. And that's a basic concept about the inductance. Then how this made to use? So instead of working with one single conductor in straight line, you just we can make this as a coil, and if a current is made to flow, and because of this current, you can look at this, because of this current, and magnetic field of this type is created. So if you are looking from this, so inside section, if you look at it, the direction of the field is upwards. Inside it is upwards, and outside it is downwards. So if you just look at it, the whole coil, around the coil, everywhere it is upwards, and outside it is downwards, then it something looks like this, a magnetic field. This is our electric current flowing, and because of this current there is a magnetic field. So this is electric current flowing, and this is our magnetic field produced. Instead of a single coil, if you think of multiple turns, then this whole thing can be viewed as just cut in the center, and see this side the current is coming towards us, here it is coming towards us, here it is going away from us, and so on. So this, the current is in the third dimension, so it is in the z direction, and the coil is, we are just looking at the two parts of the coil. Okay, when the current is flowing, the current is coming out of here, the current is coming out of here. So if you look at that, then the magnetic field produced would be in the clockwise direction, the counterclockwise direction, and the magnetic field produced here, which is the current is moving away from us, then it is produced in the clockwise direction. Now if you look at this position, then this flux line is upwards, this flux line is downwards, so they two nullify each other, and this one is downwards because of this, and because of this it is upwards, so it is nullifying here, and hence effectively what we have is a net magnetic field which is like this. So this is clockwise and counterclockwise, so this side is to the left, this side is to the right. So here we have to the left, here we have to the right. So looking at this, upside we have towards right, and downside we have towards left. So just look at it, these two are in the same direction, so they add up each other, and in turn what you can say is these two together are aiding each other, and the magnetic field produced by each turn gets added up, and hence we have a total magnetic field which is the sum of the two. So with one coil we have 1 unit of magnetic field produced. When we have two coils, two layers of that or 2 turns of it, then they add up and the strength increases. So same way, when you have multiple turns, then the strength increases multiple times, and because of which the magnetic field produced will be much stronger. And more magnetic field produced, then more these effects are found, and this is the concept of inductance. That inductance is the effect of magnetic field produced due to the current flowing in a conductor, and if the conductor is made to shape like a coil, then all the magnetic field at every point on the conductor, they get cumulated, and one cumulated magnetic field is created. And if you have multiple turns of the coil, then for each turn of the coil one set of magnetic field is created, and that they add up together, and more number of turns are used, the stronger magnetic field is created, and the stronger magnetic field is created, then the stronger opposition through the electromotive force we can feel whenever you try to make the current change. Okay, now how do you connect with the other components? This is visible, the whole effect is visible only when there is current. When there is no current, nothing like inductance is visible, and hence the inductance has to do something with current, current has to do something with the motion, motion means you are talking about kinetic energy. When you talk about capacitance, capacitance is difference in the potential energies. So this is something to do with the potential energy, whereas the resistance is the one which dissipates energy in our physical world. So the capacitance and inductance. So when we have magnetic field, then when you try to stop the current, the magnetic field will not allow the current to decay immediately, So that we can take it as there is some storage of energy which will further continue to make the current to flow even if you stop the current flowing. So this current was flowing because of some reason, and if that reason is no more existing, then because of this magnetic field the current continues to flow. So we can say that now that energy is there stored in the form of magnetic field. So the inductance stores the energy in the form of magnetic field or a kinetic energy, and capacitance stores the energy in the form of potential energy. So these two are storage, we can say, energy storage systems, whereas this one is energy dissipation. So that's it for now. We will see the how these can be used when we have different types of situations, like what happens when we have direct current, what happens when we have alternating current, how each of these components are going to behave, and how these behaviors can be made use for our purpose, and so on. So that's what expected in the coming lectures. So till then, take care, see you, bye.